Today we will analyze the response of an RC circuit when the input is a triangular voltage waveform. Consider an RC circuit. Resistor is equal to 1 kilo ohms, capacitor is 500 nanofarads. Input is a triangular waveform with time period 1 milliseconds and height equal to 1 volts. We want to find the voltage across the capacitor, voltage across the resistor, and the current flowing through the circuit. After 0 seconds, the input voltage will be available and the capacitor starts charging. Now the charging equation for the capacitor can be taken as follows. If we consider 5 microseconds to be the first time step, then the voltage across the capacitor at 5 microseconds can be calculated using the following equation. TR here is the real time, which will be equal to 5 microseconds. Now V in equal to V peak into T real minus T start by T peak. V peak here will be 1 volts, T real is 5 microseconds, T start will be 0. T peak will be 0.5 milliseconds. This V in equation will hold true for time interval between 0 to 0.5 milliseconds for the first rising slope. After the rising slope, we have a falling slope. For that, V in can be calculated using the following equation. Here, T start will be 0.5 milliseconds. And for the next rising slope, V in can be calculated using the following equation. Now, after 5 microseconds, there is a change in the input voltage, and hence the voltage across capacitor can be calculated using the following equation. If we consider, let's say 10 microseconds, then Vc of 10 microseconds will be equal to V in into 1 minus e to the power minus T real minus T start here will be 5 microseconds divided by Rc plus Vc of 5 microseconds into e to the power minus 10 microseconds minus 5 microseconds divided by Rc. So the second term is because the voltage would have charged to some initial voltage at 5 microseconds but proceeds to charge to a different voltage level at 10 microseconds. Now the voltage across the resistor can be calculated as V in minus Vc from KVL. This is how the voltage across the capacitor looks like when plotted from 0 to 1 milliseconds. We can see that it is exponentially increasing from 0 to 0.5 milliseconds. After 0.5 milliseconds, we can see that the input voltage is a falling slope. Hence, we can see the voltage across the capacitor to be decreasing until 1 milliseconds. Now, the voltage across the resistor can be calculated using the following equation from KVL. And on plotting it, we can see that voltage across resistor is increasing up to 0.5 milliseconds and after that it is decreasing. And the current flowing through the circuit will be same since R and C are in series and is calculated by dividing VR by R. Now to capture the precise charging and discharging profile of VC, the calculation is repeated in Excel with time intervals of 5 microseconds. Let's look at that. Here this is the input voltage that we are feeding to the RC circuit. At 0 seconds, the input voltage is 0 and capacitor's voltage is also 0. At 5 microseconds, the capacitor's voltage can be calculated using the equation V in into 1 minus e to the power minus T real by RC. And at 10 microseconds, the voltage across capacitor changes to this equation. E11 here is the voltage that the capacitor has charged to at 5 microseconds into e to the power minus T real minus T start will be 10 micro minus 5 micro, which is equal to 5 micro divided by RC. And this is V in into 1 minus e to the power minus 5 microseconds divided by RC. Now V in for 0 to 0.5 milliseconds for the rising slope is calculated as V peak into T real by T peak. Now after 0.5 milliseconds, this is how the V in will be calculated. V peak minus of V peak into T real minus T start by T peak. Plotting the voltage across the capacitor, this is how the graph looks like. Similarly, VR and current flowing through the circuit can be seen as follows. Let's simulate this and check. Now on simulating this, we can see that This is the input that we are feeding to the RC circuit, and the voltage across the capacitor looks like this. This is the voltage across the resistor, and current flowing through the circuit will be the same since R and C are in series. Here is the summary. We can see how the input voltage has transformed across the capacitor and the resistor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for triangular voltage input. Thank you for watching this video.